Okay, so what you've got in front of you there are the 7 fundamental SI units. SI stands for Système International. It's French. And these are the 7 original units, like they're the kind of ones that every other unit you know is made up from. Just to remind you of them, the most sort of famous, popular, fundamental ones are the second, the meter, the kilogram, the candela, which is for luminosity. You won't really ever use that in our course. The mole, which you'll certainly use in chemistry. The ampere, which is used for electrical current. And the Kelvin, which again we don't use much in our course, but it's kind of a better way of measuring temperature than degrees Celsius. So anyway, what I'm going to do is talk to you about derived SI units, and I'm going to show you how to derive the unit Newton. There it is, the Newton. And there's a fairly easy way to go about this. What you've got to do is find an equation which has force in it. Obviously force is what we measure newtons in. And have a look at what you've got. So I'm going to go with F equals ma. F equals ma. Force is mass times acceleration. Now what I'm going to do with that information is look at the units. So I know that this is a newton, and I know that the mass is in kilos, and the acceleration is in meters per second squared. And actually I've solved this straight away because I was very lucky that kilo is a fundamental SI unit, meter is a fundamental SI unit, and second is a fundamental SI unit. So the proper fundamental way to express a newton is the kilogram meter per second squared. So my challenge to you then is to do this for a couple of other units. So let's just move all that out of the way. I would like you to find the following fundamental versions of the unit. The joule, the unit for energy. The coulomb, the unit for charge. And finally, the pascal, the unit for pressure. Okay, so your challenge is to find the fundamental versions of those 3 units. Good luck.